Now I will discuss about the D block element. Before going to the D block element, I want to draw the electronic configuration of sodium. Sodium having atomic number 11. The electronic configuration of sodium is 1s2, 2s2, 2p6, 3s1. In case of sodium, the last electron goes to the s orbital of valency cell. Here the valence cell is your 3, that is your called M cell. So we can write the definition of S block element. S block element is the element in which the last electron goes to the s orbital of the valence cell is called S block element. Like that, suppose I want to draw the electronic configuration of carbon. Carbon having atomic number 6. The electronic configuration of carbon is your 1s2, 2s2, 2p2. In carbon, the last electron goes to the p orbital of the valency cell. As a result, carbon atom belongs to the p block element and sodium atom belongs to the S block element. Since the last electron goes to the p orbital of the valency cell and carbon belongs to the p block element, so we can write the definition of p block element is the element in which the last electron goes to the p orbital of the valency cell. But if I will draw the electronic configuration of zinc, zinc having atomic number 30, its electronic configuration is your 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Here the last electron goes to the d orbital. From this electronic configuration, it is clear that here the valency cell equal to 4, that is your M cell. In case of S block element and P block element, S block element related to the S orbital of the valence cell, P block element related to the P orbital of the valency cell. But remember, in zinc, the valency cell does not include the d orbital. That means the d orbital does not belong to the valency cell. Here the valence cell is N cell, but d orbital belongs to the 3 cell, that is your M cell. So, for writing the definition of D block element, we cannot write the element in which the last electron goes to the d orbital of the valency cell, because d orbital belongs to M cell and M cell is not the valence cell. Here N cell is the valency cell. Suppose I want to draw the electronic configuration of zinc according to the cell. This is your K cell, this is your L cell, this is your M cell, this is your N cell. K cell contain 1 orbital, that is your 1s. L cell contain 2s and 2p orbital. M cell contain 3s, 3p, 3d orbital. N cell contain 4s orbital. Here 3d orbital belongs to the M cell, that means before the valency cell. This is your valency cell and this cell present before the valency cell, and this cell is called penultimate cell. Penultimate cell. Remember this word? Before valency cell, towards the nucleus, that is this cell called penultimate cell. Before penultimate cell, this cell is your called anti-penultimate cell. Anti-penultimate cell. Remember these two words. That is your one is your penultimate cell, another is your anti-penultimate cell. The d orbital belongs to the penultimate cell, so we can write the definition of d block element. The element in which the last electron goes to the d orbital of the penultimate cell. Similarly, in case of f block element, it is bound to write the last electron goes to the f orbital of the anti-penultimate cell. But in case of d block element, it is bound to write the last electron goes to the d orbital of the penultimate cell. So we can write a definition for d block element. The elements in which the last electron goes to the d orbital, or you can write enters to the d orbital of penultimate cell. Penultimate cell. This is the definition of d block element. D block element. Remember, you can write d orbital of the valency cell. Look at that. This is your modern periodic table. In this modern periodic table, this part is called d block elements, because if I want to draw the electronic configuration of these elements, then the last electron of each element present in the d block goes to the d orbital of penultimate cell. Look at the periodic table. The element present in group 3, group 4, group 5, group 6, group 7, group 8, group 9, group 10, group 11 and group 12 are called d block element. The d block elements are called transition elements. The general outermost cell electronic configuration of d block element is n-1 d1 to 10 ns0 to 2. It can be easily verified by drawing the electronic configuration of the element present in the d block. The elements present in group 3 to 12 are called d block element. Look at that. This is your d block. The d block again classified into 4 series, such as first transition series, second transition series, third transition series, fourth transition series. This part is your called first transition series. It belongs to the fourth period. It consists of element from scandium to zinc. This is your said to be second transition series. It consists of element from yttrium to cadmium. This part is your called third transition series. It consists of element from lanthanum, hafnium to mercury. This part is your called fourth transition series. It consists of element from actinium. Next is your Rutherfordium to CN. The D block elements are classified into four series. The D block elements are classified into four series. Such as number one is your fast transition series, or you can also call 3D series, 3D transition series. Second is your second transition series, or you can also call 4D transition series. Similarly, we can also think about the third number series, that is your third transition series, or you can think about 5D transition series, and you can also think about the fourth number is your fourth transition series, or 6D transition series. At first, I will discuss about the fast transition series. What is fast transition series? This series belongs to the fourth period. This series includes elements from scandium having atomic number that is equal to 21 to zinc that is having atomic number 30. If you want to study the electronic configuration of scandium to zinc, then the last electron gradually filled in the 3D orbitals. So this transition series is called 3D transition series. So we can write in this transition series, the 3D orbitals are gradually filled. So this series is called 3D series. Next I will discuss about the second transition series, that is your 4D transition series. Second transition series, that is called also 4D transition series. This series belongs to the fifth period. This series belongs to the fifth period. Here the elements starts from yttrium to cadmium. So you can write this series includes elements from yttrium having atomic number 39 to cadmium having atomic number 48. In this series, the 4d orbital gradually filled. So this series is called. So this series also called 4d transition series. 4d transition series. Now I will discuss about the third transition series, that is your 5d transition. Third transition series, or you can think about that is your 5d transition series. We can write the point. This series belongs to the sixth period. And the second point is that this series includes element that is your lanthanum having symbol La, and atomic number is your 57. Then hafnium having atomic number 72 up to Hg, that is your mercury, atomic number is equal to 80. And the third point is your, in this series the 5d orbital gradually filled. So this series also called 5d transition series. 5d transition series. Now I will discuss about the fourth transition series, or you can also call that is your 6d transition series. And we can write the points. This series belongs to the seventh period, that is your last period of the modern periodic table. And we can write the second point. This series includes the element that is your actinium Ac, and having atomic number that is your 89. Then it included the elements from rutherfordium Rf having atomic number that is your 1042, Cn having atomic number 112. In this series we can write 6d orbital gradually filled. So this series also called 6d transition series. This is all about the fourth series of the D block. Now I will explain about the characteristics of D block element. Characteristics of D block element. D block elements are called heavy metals. So first point is these are heavy metal. They are having high boiling point and melting point. D block elements having high melting point and boiling point. D block element can form complex compound due to vacant d orbital. D block element can form colored compound. D block element having variable oxidation number, variable oxidation state, or you can also about the number variable oxidation state means more than 2 oxidation state. For example, copper +1 +2. This is all about the D block element. Now I will discuss about the F block element. F block element. Take an example of F block element, cerium. It's a electronic configuration. Most includes 4f2, 6s2, 5d0. Here the last electron goes to the 4f orbital, and the 4f orbital belongs to the anti-penultimate cell. Here the valence cell is your 6, and the penultimate cell is your 5, and the anti-penultimate cell is your 4. So you can write a definition for F block element is the elements in which the last electron enters into the F orbital of the anti-penultimate cell is called F block element. Look at that. This part is your called F block element. The F block element classified into 2 series. One is your lanthanide series, another is your actinide series. The general outermost cell electronic configuration is n-2, n-2, F1 to 14, n-1, D0 or 1. This can be clearly explained by the help of drawing the electronic configuration of all the elements present in the F block. The F block elements are classified into 2 parts. That is one is your lanthanide series, another is your actinide series. Each series contains 14 elements. So we can write the F block element. The F block elements can be classified into 2 series such as number 1 is your lanthanide series, number 2 is your actinide series. At first I will discuss about the lanthanide series. Lanthanide series, it is the first series which include the elements lanthanum having atomic number 57, and also include the elements cerium having atomic number 58, to lutetium having atomic number 71. Remember, if you think about the element lanthanum, then it belongs to the D block element. But remember one important point, it obeys all the characteristics property of F block element. No doubt the last electron of lanthanum goes to the d orbital, but it obeys all the characteristics of F block, so you can include the lanthanum in the F block element list. But it is present in the D block element. Suppose a question will ask in exam, lanthanum present in which block? then obviously you can think about it is present in the D block element according to the definition. But remember, when we will discuss about the characteristics of F block element, then we can include the lanthanum in F block, but actually it is present in the D block element, but it obeys all the characteristics property of F block. So you can consider lanthanum in F block element when we will study about the characteristics property of lanthanide series. Remember one important point, lanthanum belongs to D block element, but it obeys all the characteristics property of F block element. When you will study the characteristics of F block element, then you can think about the lanthanum, but when a question will ask in exam, then you can write, it is bound to write in the D block element. Similarly, if you think about the actinide series, the actinide series include actinium having atomic number 89 and starts from thorium having atomic number 90 to lawrencium having atomic number 103. Both lanthanide and actinide series contain 14 elements. Remember, both lanthanide and actinide contain 14 elements. Here we can also think about the actinium in actinide series. It also obeys the characteristics property of F block, but it is present in the D block elements. So when we will study about the lanthanide and actinide series characteristics, then we think about the element lanthanum and actinium. Lanthanum in lanthanide series, actinide in actinide series. This series is called lanthanide because this series starts from lanthanum, that means it follows lanthanum. This series is called actinide series because this series follows the actinium. After actinium, you think about the actinide series, so it is called actinide series. Every series contains 14 elements, so we can write each series contain 14 elements. Suppose a question will ask, lanthanum belongs to which block? Then your answer is your D block. Actinium belongs to which block? Then your answer is your D block. Don't want these two elements in the F block element list, but it obeys all the characteristic property of F block elements. Suppose the question will ask, lanthanide belongs to which block? Lanthanide means lanthanide series, and lanthanide series elements present in the F block. So we can write F block. Remember, lanthanum, that is your said to be lanthanum belongs to D block, but lanthanide series means it is included in the F block elements. That means you think about cerium to lutetium. Similarly, actinium belongs to D block, but actinides belongs to F block. Actinide series means actually it starts from thorium to lawrencium. We can write a point, the elements of lanthanides are called rare earth element. F block element is also called inner transition element. Now I will discuss about the characteristics of F block element. Characteristics of F block element. What are the characteristics of F block element? Like dear Peter, these elements are heavy metal. So you can write the F block elements are heavy metal. They having high melting point and boiling point. They shows variable oxidation state. They shows variable oxidation state. They have a tendency to form complex compound. They have a tendency to form complex compound. They have a tendency to form complex compound. This is all about your F block element.